Hey everyone, and welcome. I guess we're going to wait a few more minutes for people to join. Probably start around 5 past. I think because we're recording it this time specifically, um, probably a lot of people are choosing to watch the recording instead, which is cool. Yeah, so we'll give it a few more minutes. Just to raise of hands, how many of you folks have used or worked with GCP before? Nice, nice. Okay, let's start in 2 minutes. Okay, everyone. Thank you so much for joining us today. We are going to have a very exciting live session ahead. We're going to cover TTPs, tool techniques, and uh, procedures for gaining situational awareness in GCP. So let's go ahead. Just to really quickly introduce myself, uh, I am Ian Austin. I have been previously a system administrator, security engineer. Um, I'm still a system administrator, I guess. I'm still a penetration tester now, so we do engagements for our clients in on-premises, and that's something that I really enjoy as well, and some of my team also do. I really enjoy security research. I haven't done quite as much as I'd like to in the last year, but that's just because I've been pretty busy with Pwned Labs. And I guess I'm a content creator of sorts. So I create kind of content, and mm, we have like over 35 free labs now on the platform. So yeah. Okay, so today we are going to cover an introduction to GCP and Google Workspace. We want to really understand how we can visualize IAM configuration from the perspective of gaining a foothold in an environment. So as a red teamer, we want to see how we can discover the allowed IAM permissions. We'll kind of see that sometimes we don't have permissions at a project level that we can see. So we need to find some way to kind of identify those permissions that we've been given, and we'll spend some time doing that as well. We will then so how to discover service account attack paths using some very dangerous permissions that allow for lateral movement um, in between service accounts, and how to really identify and get situational awareness in the context of each account. We'll then show how we can go about enumerating Google Cloud Storage using HMAC keys and some of the gotchas with using them. and also look to, um, from a blue team perspective, we'll look at some of the implications of HMAC keys as well. We will then look at identifying some malicious activity using Google Cloud logging um, to see, some of the dangerous permissions that we abused earlier. Finally, there is also a capture the flag. So there is a prize for first blood. I'm sure you can get what the prize will be. And yeah, so hopefully that's a really fun CTF. It's a little bit tricky, but very fun. Yeah, so let's get started with the intro. Okay, so Google Cloud Platform began in April 2008, so a little bit after AWS. AWS obviously had the benefit of being the market mover. They uh, effectively created the market, and Google Cloud have kind of been catching up. It just goes to show that even if you delay entering a market by a few years, then that can have a big effect on um, the size of the market you capture. Um, so yeah, they launched in April 2008 with the preview release of Google App Engine, and then in May 2010 they also introduced Google Cloud Storage, which for those of you more familiar with Amazon, maybe that's effectively the Google equivalent of S3. And
Ian,
shortly there.
hi. Sorry to interrupt, but I'm not sure that you're sharing your slides. I can't see your screen.
Oh my goodness, Tara, thank you so much. I mean, I keep on doing this. This is terrible. Um, so let me just very quickly. Thank you, Tara.
No problem. I'm just glad it wasn't on my end.
Yeah, yeah. So that's the total. It's me. That's the agenda. I will actually share with you folks now the PDF as well. Um, yeah. All right. Let me just share the PDF for you. Um, oh, actually, that's got the CTF slide in it. Right. Anyway, let's carry on going. I'm just checking this is being recorded actually, very quickly. Zoom's taking. Yeah. Okay, cool. The meeting's being recorded. Um, so yeah, in May 2010, Google GCP introduced Google Cloud Storage, and shortly thereafter, Google BigQuery. There are now over 150 GCP services, so maybe not quite as many as AWS and Azure, but it's creating new services all the time. And it is also gaining market share. So, kind of the market dynamics that we're seeing here is that it kind of looks like over the last few years, like the market share is consolidating around the big three. So, AWS, Azure, and GCP are increasing their market share or staying the same, maybe increasing by like 1% each year, or kind of staying the same. Whereas the others, the long tail of cloud providers, which will be kind of like Oracle, IBM, Tencent, Salesforce, Alibaba, etc., DigitalOcean, are kind of the longer tail of providers that seem to be losing market share. So that's just kind of like a trend that is worth pointing out about the consolidation around the big three. Okay, so to give an overview of GCP, it says Azure offers, that is a typo. So GCP offers software as a service, SaaS, infrastructure as a service, IaaS, and also platform as a service. Google's acquisition of Mandiant and Wiz, most recently with Wiz, positions it as a leader in cybersecurity through its unified threat intelligence and risk management. So, you have Microsoft Sentinel wanting to make a big play, being able to get insights into and protect AWS and GCP, and with the acquisition of Wiz and backed by the expertise of Mandiant, it looks like Google Cloud is looking to make a play itself to become, the leader across cloud generally in terms of cloud security. It's worth noting as well that Google is the birthplace of Kubernetes. So GCP is a strong fit for organizations who leverage this technology or indeed who already use Google Workspace. I mean, if you're a startup nowadays, you kind of have a very clear choice between Gmail and Outlook. I think from an individual perspective, Gmail really owns the market. Just like Chrome owns the browser space, Gmail is kind of mostly owning the individual webmail space. So I think when I was checking this, I think Google Workspace makes like it owns over 50, potentially to 60%, maybe even a little bit more in terms of market share. So it's obviously a extremely well adopted product, the market leader. And if you already use Google Workspace, then maybe GCP is a good fit as well. So I would expect to see the market share of GCP increasing in the years ahead as well. Okay, so what are these kind of terms then? Infrastructure as a service, platform as a service, etc. Well, with infrastructure as a service, you manage the data, the configuration, the application code, the scaling, runtime, and the operating system. An example of this would be a GCP VM instance in the compute engine service. Then you have platform as a service that lets you manage the data, configuration, application code, and scaling. Examples of this includes Google App Engine and Cloud Run. Then we have software as a service. I'm not sure what happened to that icon. So with SaaS, essentially, like whether it's Pwned Labs or Google Workspace or whatever, you manage the data and configuration and use the product, but you don't have any access to the underlying stuff. Importantly, just like Microsoft, really, Google also offers identity as a service. Now, in terms of identity, this is one of Google's really strong points, to be honest with you. When compared to providers, this is definitely an area that seems very robust, and they've really hardened this service as well to make it a little bit harder for hackers to enumerate stuff. So identity as a service is a standalone solution that manages users and groups. It integrates with Google Workspace and GCP, and it supports federation. So you can use your own provider, such as Active Directory, or you could use Entra ID as well. So effectively, when companies are making the jump to cloud, they're obviously planning very carefully, and they're thinking, well, maybe I want to use one provider. Maybe we're very tied to them. We have contracts in place with them already. Or maybe they're kind of like thinking, well, we've got the opportunity to really use multiple providers for resilience and not to be reliant upon a single provider, and we can choose the specific things that we think each provider is very strong at. So that might be an approach you see with multi-cloud as well. Okay, so the unit of separation in terms of isolation in Google Cloud Platform are projects. So in AWS, you may think of account, AWS accounts are the unit of isolation. In Azure, potentially resource groups, the unit of isolation there. In GCP, you have a project, so effectively a group of resources that's isolated from other resources. These act as logical containers for everything that you want to build and deploy, and can include services across key categories, including compute, storage, big data, machine learning, and application services. It's worth noting again that for companies that have a requirement for big data, machine learning, then GCP is very strong in this area as well. In terms of interacting with GCP, we can use the Google Cloud Web Console, cloud.google.com, to interact with GCP visually, which is sometimes handy to do, to be honest with you. While we can also use the gcloud CLI and gsutil that make it easy to interact with GCP services from the command line. So in terms of abusing GCP resources and services and misconfigurations, then obviously there's many things we can do in the command line that we can't really do from the console, although you do have Cloud Shell there as well. So gcloud allows management of compute resources, IAM roles, networking, various other services that GCP offers. And it is a go-to tool for automation and DevOps with folks who use GCP. On the other hand, gsutil is a separate utility because of the importance and kind of the need to automate cloud storage tasks. gsutil is a separate utility provided by Google that streamlines cloud storage tasks such as uploads, downloads, permission management, etc. And we'll get hands-on with both today. Fine. So then you have GCP IAM principles. They can also be referred to as IAM members. GCP IAM principles represent the identities that are able to access and potentially manage resources. So each principal, such as a user, a Google group, a service account, or a domain, is uniquely identified by an email-like string. And this string also includes the project name, or the project identifier, rather. IAM policies can be created to define who, the principal, can perform what on which resources. And it allows for really fine-grained access control across the platform. As mentioned in GCP, IAM principles are referred to as members within the context of IAM policy bindings. So GCP IAM is actually binding based. So instead of just showing a list of users and if you click into a user and you see the policies there, it kind of shows more like a table of bindings. So it doesn't really track a global registry of all possible principles that you can see. You really see at a project level the bindings only. So if someone has been given viewer access at the project level, or maybe some other permission, then they will be accessible in the GCP IAM policy view. If an account hasn't been given any permissions there, then it won't be, or sorry, if a principal hasn't been given any permissions at the project level, then you won't be able to see it in the GCP IAM project list. So in terms of, if you're maybe more familiar with AWS, then we kind of attach policies to principals, whether it's a user, a role. In Microsoft in Azure, then you can be assigned a custom role or a role, various roles for Entra or for Azure. But with GCP, you are kind of bound to a policy, and so this kind of terminology of a binding is unique to GCP. Okay, so let's just add the a little timer, so it's a bit easier to follow. Okay, so we've kind of spoken a little bit about the different principles that are available in GCP. One of those principal types are service accounts. So service accounts in GCP, maybe if you're more familiar with service roles in AWS or managed identities, maybe in Azure. So that's effectively a little bit what service accounts are in GCP. So they are special identities that can be used by applications. They can be associated with resources, just like service roles in AWS and managed identities in Azure. And other services to authenticate and access resources securely. So these service accounts function like users, but are actually intended for automated and non-human interaction across GCP. So how can we authenticate as a service account? Well, first we need a key file. So typically a JSON key file, although you can create different formats there. So we specify G-Cloud and then the action auth, and then we use the activate service account method, and we specify a parameter of key file, and then we provide the key file and log in as the service account, or effectively activate the service account credentials. It's worth noting that when you spin up a new organization in GCP, then service account key files are not allowed by default. They're not generated by default. There's an organizational policy that prevents the creation of service account key files. But if you're going to do any serious work in GCP, you probably want to enable key files. However, they do come with a risk. They are obviously static, long-lived credentials that won't expire for thousands of years. And so if accidentally exposed, they can pose a very serious risk to your environment. There's many key files that have been exposed in various GitHub projects online, Firebase, etc., for developers who are looking to create apps. And so you often see like Firebase key files and various other key files there. It's also worth noting that by default, then if Google automatically detects a leaked key file in GitLab, GitHub, or Bitbucket, or something like this, then they will, by default, automatically invalidate it. However, again, you can change this setting at the organizational level. So instead of having GCP automatically invalidate them when they detect them, you can choose to only have GCP invalidate them on a proof of, you know, malicious activity. So it's obviously best to keep that security default and not change it, to be honest. Um, so yeah, the move away from key file creation. I say the move away. It's not like many customers. Well, probably many customers are moving away, but also I suspect if we did an audit of all GCP customers, a majority of them would still be using service account key files. So GCP disabled service account key creation by default on June 30th, 2022, as part of their effort to enforce keyless authentication via workload identity and IAM roles. And this would also, of course, reduce the risk from exposed long-lived credentials. However, as mentioned, admins can enable service account key creation. Um, we'll kind of touch on this in the bootcamp later this year as well, but it's worth noting that while there are security benefits to using workload identity federation, this can itself also be misconfigured. It leverages the OpenID Connect, and so as we've seen with AWS as well, this is something that's potentially be misconfigured and might allow threat actors to gain access and access resources. So it's not a security panacea, it's a step forward, but it still means it can still be misconfigured, essentially. Okay, so before we dive in anymore, just want to ask if people maybe have some initial questions. Okay, let's carry on. I think we'll maybe take a break in like half an hour, just to kind of split the session into two halves. Okay, so in terms of enumerating IAM policy bindings, um, if a principal that's been compromised is able to list the IAM policy bindings for a specified GCP project, this can help us to gain situational awareness about some of the other principals that have been given permissions in an environment. And so cloud projects, the action projects, the method get IAM policy, and then we specify the project ID there. So in this case here, if we take a look at the screenshot, then we see various service accounts. And the first component of a service account is obviously the names, such as element ML that we see there. Then after the @ we have the kind of the email or the domain. The first section there is the project name. So this is the GCP project. So grprod1 is the project that this service account was created in. And then the domain suffix im.gs gserviceaccount.com is obviously a Google owned API endpoint. And so, yeah, as mentioned, a key point to note is that the IAM policies at the project level only reveals service accounts been granted roles at that level. If an account has been granted access to secrets or an individual Google Cloud Storage bucket, then this would not be listed in that kind of view. And there may be other permissions and service accounts that have been assigned. We are going to do a quick demo now on visualizing IAM policy bindings. It can be, of course, very difficult to review the text-based output in the CLI, even for smaller environments. So we can very quickly visualize the IAM policy bindings using IAM policy visualize. But first, I just want to give you an example, really, of what it looks like from the CLI first. So just let's take a 2-minute pause. So I just log in. So I'm now logged in. Let's run the previous command. Okay, so this is an example of the IAM bindings that we see here for the project named grproj1. And this is the user that I'm logged in as. So you see a whole bunch of stuff here. And even this, to be honest with you, is not so bad. It's not too much. But even here, would struggle to really see, well, many people have been assigned this particular role, or, you know, we'd kind of struggle to make sense of it really from a text perspective. Obviously, this is YAML. We can also format the output to be JSON instead if we find that easier. But let's do the demo of IAM policy visualize. So this is a project that's been created by Ayush Hack, who is part of the Pwned Labs team. So we are going to demo his project now. But first, let's get the credentials. So I'm just going to log into the jump box. So effectively, we have a pen test jump box that the client has given us. That's the scenario. So we'll just okay. So we got the credentials there. Got the token. So let's go ahead and disconnect from the remote host. Okay, and also from the VPN. With Google is that the access tokens start with YA29. So you may be familiar with access tokens from Microsoft that have EY, and you can put them into jwt.io. In terms of Google's access tokens, they are actually opaque. So you can't actually really see what's inside them. It's all proprietary to Google. So if we try and go to jwt.io, whoops, oh dear, such a, okay. Yeah, so there we have like a typical JSON web token. These are proprietary access tokens, and obviously that's not going to work here. So we can't really see what's inside that. Okay, so we have set our access token locally. Now we can use the commands gcloud projects get IAM policy. We want the project name, which is gr prod1, and then we need to provide the access token file of token.txt. So, yep, there we have it. That is the list that we saw previously. Not particularly user-friendly. So we can go to opt and policy visualize. And we'll run this command again, but instead this time we'll specify the output format of JSON because this particular tool expects the format in JSON, so we can export, provide the output of the gcloud command in JSON also. And we'll save that to IAM policy bindings. Bindings.json. Yeah, that does help if like the tokens reference that properly. Okay. So hopefully now if we check out, we call it IAM policy. Oops. Yeah, so we see that's exactly what we saw earlier, but just in JSON format instead. Okay. Now what we can do is run this tool. So we run main.py, and then we put the we specify as an argument the file that we just exported. Feel free to check out the code in GitHub before you run it. Okay, so it says the IAM policy visualization is saved to here. So let's open that up. And you have it here. So this obviously is maybe not the most convenient way to view it. Also, truth be told, but it's at least a little bit better than just looking at the text. So here, for example, we see there's a username 29 gmail.com. So this is obviously an external user with a personal Gmail account that's been added to this GCP project. This is actually very bad because there's no real way to remove permissions, or there's no real way to remove these users from a project if they haven't been assigned permissions at the top level. Like there's no way to report on this really easily for admins. So this would be classified as a high security risk, having a personal account in a corporate GCP. And then we have various service accounts. We've got a user named Ian at giganticshopping.com. We've seen that. We've got another user there. We see various service accounts have been assigned the editor role at the project level. This is a very dangerous permission to have, to be honest with you. That gives potentially a complete control over the project. Well, not potentially, it gives complete control over the project. And yeah, so here we have a group named contractors at shopgigantic.com, and that is a member of the artifact registry reader role. And so is this service account here named artifact. So that kind of makes sense that the artifact service account has access to the artifact registry reader role. So yeah, this is kind of this is an evolving tool that is in active development and will kind of increase in functionality and usability. But yeah, this is, you can kind of see now how that's like just a step up from looking at this, which is just a little bit harder to read from a human perspective. So yeah, that is visualizing IAM policy bindings at project level. And once we compromise an identity, then we're able to gain situational awareness and see, well, okay, what identities do we have and what permissions have they been given, and start to figure out, well, how do people use this environment, who's accessing what, and stuff like that. We have some labs on the platform around this as well. There are other tools to visualize this as well, also from a graph perspective, and not just an image. And in the bootcamp, we'll touch upon various tools as well. Okay, so if we've compromised an identity in GCP, or a principal rather, what if the principal doesn't have permissions to either list the service account or retrieve the IAM policy bindings for a specific GCP project? Well, in that case, we can effectively do a little bit like various brute force tools that exist for AWS, such as AWS Enumerator. We can leverage the same sort of technique in GCP using the test IAM permissions API endpoint or feature in GCP. Effectively, we can buzz this endpoint for various permissions and try to identify what we have access to. So there is a nice tool here named GCP Permissions Checker. I've put the GitHub repo there, and then you can just run it there. So it expects a key file. Yeah, so let's jump into that one. So with this one, then GCP Permissions Checker will authenticate as a service account using the key file that we provide as an argument. And then it reads a list of permissions from the permissions.txt that comes with the repo. It then calls the test IAM permissions API in batches of check which permissions are valid for that service account on the specified GCP project. So let's go ahead and do another demo. I think we already have actually. Yeah, so GCP permissions checker. You then need to install the requirements, but obviously we've done that already. So we copied the key file into the repo. Now we can go ahead and run it. It says the service account credentials are loaded successfully. It provides the service account email, which in this case, the principle that we've compromised is JIT app. So JIT may be just in time, or maybe it's some other acronym. And then it has the kind of the project name and the GCP suffix. So that is going through it, reports the project ID, the project name, which in this case is the same. Sometimes you can specify project names such as test or prod or dev. And because those project names will exist in other environments, the actual project ID that gets created has a random suffix, a six-digit suffix appended to it, just to ensure uniqueness globally. This isn't the quickest tool, to be honest with you. It takes maybe 4 or 5 minutes, but we see a nice progress bar, so we kind of know it's doing stuff, and hopefully it finds some permissions that we're able to use. So let's just leave that for a minute there. If anyone does have any questions, feel free to shout.
I got a question. So this is talking about service accounts specifically. Would this same kind of tactic work for accounts that are not service accounts, such as like that like read-only Gmail user, or is this only for service accounts? I guess I'm just trying to wrap my head around that.
Yeah, great question. I believe the test line permissions API is for all principals.
Okay.
We can check that. We can check that quickly now while we're waiting for that. So test and permissions. So it seems that there are various test line permissions endpoints. One is specifically available for service accounts. So it uses this method, which is projects.serviceaccounts.testLinePermissions. This is the HTTP request we need to send to query that. And then there's another one here for compute instances. So really allowing the compute instance permissions they have or the identities associated with them. So yeah, great question. It seems just to be service accounts. But if we find it's for all principles, we can obviously, if someone finds it's for all principles, we can update the channel. So yeah, just to mention to you folks that the slides will be available as soon as the CTF stuff, because it's got the CTF slide as well. So I don't want to give people an unfair start. Okay, almost done. Mhm. There's quite a few potential permissions, obviously, that we can have. So it's kind of just going through that. And if it does find that we have access to something, then it should just kind of spit it out at one. All right. So it's found secret manager.locations.get, locations.list, secrets.get, secrets.get IAM policy, and secrets.list. So it can list secrets in an environment and also retrieve the secret values. Okay, so that seems interesting. And that is done. Okay, so we should have the key file here. We do. So let's go ahead and activate that key file now. Okay, so that obviously was the command gcloud auth, activate service account, and then we provided the key file there and the key file name. If you want to check out what the key file looks like, then it's just effectively this. So it is a JSON file that has various key pairs such as type, project ID, private key ID, and the private key. And this is an SSH key. It's encoded here in JSON. And various other functions. So the client ID, that is the name of the service account. Various other things. So let's go ahead. We've now activated that key file. So instead of using the token.text, we logged into the VM instance, the GCP VM instance, and we queried the metadata, which retrieved the access key for a service account that was associated with that VM, and then we kind of saved that to token.json and then used the access key when we're issuing our gcloud commands. But if we have a key file, then we can obviously activate the key file, and the credentials last for a lot longer than the access token, which I think has an expiry maybe of 10 minutes, something like that. I could be wrong. I have to check. So we saw that we had permission to list the secret manager secrets potentially. So let's go ahead and run this command. So gcloud secrets list, and we specify a project name of grprod1. Okay, we see a secret here named orchestrator. So let's go ahead and retrieve the secrets of that key. All right, so there we have some credentials. Admin with a password of gigantic. Awesome. And so yeah, hopefully that was handy and showed, if we tried to actually view the policy. So let's try running that command now. Actually wanted to run gcloud projects get policy, and then the project name is grprod1, and we're denied access. We don't have any issues there. So that is a really nice technique to gain situational awareness in a GCP environment if we have compromised a service account, leveraging the test what is it? Yes, the test IAM permissions. My brain just went dead there. Leveraging the test IAM permissions API. Okay, so the next, this one. What's time? 36. So that's probably a good time for like a 10-minute break. To be honest, we're about halfway through. Or actually, maybe we're okay for a break. If you want a break, just to stretch your leg for 5 minutes, let me know. Or if you're okay to power through, let me know. Okay, I think we're okay to maybe power through then. Okay, so yeah, service accounts are very powerful identities in GCP that effectively do the heavy lifting. User accounts are kind of not intended for production workloads. Instead, we should use service accounts, and they are assigned a lot of permissions potentially. So abusing us can allow us to escalate our privileges or move laterally within a project and even across project in an environment. Attack of a service account using key files that might have been created for it through HMAC keys potentially, which are for Google Cloud Storage, through workload identity federation, or by exploiting permissions such as IAM service accounts .actas, implicit delegation, or get access token, or sign JWT. So there are various kind of dangerous permissions that allow a service account to either act as another service account, to have another service account be kind of delegated to perform actions as the other account, to get a token as the other account, or to sign a JWT as another account and exchange that signed JWT for an access token. So if there's kind of one weak link, and that weak link allows us to use, let's say, a compromised service account key file to gain access to the security environment of a G Cloud project, then potentially we can start to use some of these dangerous permissions to move laterally to other service accounts, even though we might not have keys for them or credentials for them. So yeah, these permissions above, with the exception of implicit delegation, allow crafting access tokens or impersonating the service account directly. So yeah, let's go ahead and how we can do that. So we have a compromised principal in a GCP environment. Obviously, if we want an engagement for gigantic retail, we've compromised the principal runner, grprod1.im service account, gserviceaccount.com. So the runner service account, we're operating in the context of this service account, and now we need to check if it's been granted any of these dangerous permissions on other service accounts. So probably the first thing we need to do is to get a list of potential service accounts that we might have some potentially dangerous, a way of controlling it. So what we can do is use this command here to get the IAM policy, and then save this, effectively extract the service account email addresses from it and save it to service accounts.txt. So let's go ahead and do that. So hopefully our token.txt from the pen test credentials is still valid. If not, we'll have to log back into the instance. Okay, it still seems to be valid. So cat service accounts.txt. And we see there are a bunch of service accounts in this environment. So we can start looping through each service account, say, well, have I got any of these permissions on this one or this one or this one or this one, and start enumerating our permissions that way. So we're authenticated as the runner account already using G Cloud. We're not using a token. So let's go ahead and run this command next. So effectively, this says for service account in the service accounts file, for each instance of a service account in the service accounts file, do sends this request. So it needs an access token. And so we get the access token this way from the G Cloud auth print access token command. So that will populate the access token there. We then send a request to iam.googleapis.com with this path of v1 project service accounts, and then the service account email, which is the variable here that it's reading from the text file, and then to the test IAM permissions endpoint. And it is sending these permissions, and if any of those permissions are allowed, this endpoint here will kind of echo the permission back. And so any permissions that are echoed back, we'll kind of see that as us having permissions on a specific account. So let's go ahead and run that. So it's checking. Service account was not found, apparently. Oh, that's because we're still authenticated as JITA. I haven't logged in as runner yet. That would help if I had done that. Give me 1 second while I log in with the correct service account. Okay, so the service account credentials that we want to activate are for the service account runner. So if we've compromised this service account here, we've got a key file. Let's go ahead and activate it. That's obviously the list of service accounts that we have. And then let's try and loop through and see what permissions we have. Okay, so for the artifact service account, we have the ability to sign JWT. So that's quite an interesting abusable permission there. And then what else? Then for Terraform, for the Terraform service account, we have implicit delegation. So that effectively allows us to leverage the permissions that that target account has. So if this Terraform account is able to get an access token for another service account, then we can effectively act as a delegate, and we can say, well, we want to get an access token for this third account using this second account that we're delegating, or that's delegating access to us. Yeah, so that's kind of how we can abuse that one. But let's focus on the signed JWT permission for now. So the process really of abusing the iam.serviceaccounts.signed JWT permission is below. So first, we confirmed that the signed JWT permission is granted on the target SA. So there's a binding in the IAM project that says for this principal, the target service account binds this role that contains this permission with this kind of this other account that we want to delegate access or to be able to sign JWT as us. So the next step is to create a JWT with the target service account and token details. We then need to sign the JWT using the signed JWT API as the attacker. We can then exchange this signed JWT at oauth2.googleapis.com/token for an access token. And we can then use that token to act as a target service account across GCP services. So we can either leverage native API calls and the access token using curl or PowerShell, or we can obviously save it to a local file and reference that using the gcloud client. So let's go ahead and create the JWT claim set first. This command here effectively creates a very basic skeleton claims.json. The target email or the target service account already. That's artifact, the artifact service account that we have, that was all we have the sign JWT permission for or on. And then we're just making sure that the expiry dates are valid as well. So let's go ahead and run that command. And then check out what got created. Okay, so that's what got created. Next, we can sign that claims.json. So here we're using the gcloud IAM action with the service accounts method, or the signed JWT method against the claims.json. we're then creating a signed JWT.text, and we're doing it for the artifact service scope. So let's go ahead and sign that. And it created a signed JWT. So let's check out what that looks like. So that is actually EY. If we put this into tokens, JWT.io, we see. Not too much information, basically. Effectively, what we already provided the API endpoint with. So yeah, Google tokens are not particularly descriptive when compared to Microsoft tokens. Okay, so now we have our signed JWT. Then we can go ahead and exchange it for an access token and be able to do stuff as that service account. So we can send a request, post request to oauth2.googleapis.com/token. And with this payload here. So the assertion is the signed JWT that we created. And we're just using JQ to extract the access token from the response. Okay, amazing. So we have an access token there for the target service account, that is artifact. So at this point, we could start to enumerate resources in GCP and see what the artifact service account has access to. Maybe it has access to artifact registry or something like that. So yeah, it's also worth noting that if you have the expiry date, and it's obviously like in an epoch format, you can get the human readable date just using the date by command. We saw also there was another account that we had implicit delegation on. That was Terraform. So the runner account also has implicit delegation on the Terraform account. And if we wanted to abuse that, obviously we see here, we're sending a post request to the imcredentials.googleapis.com API endpoint with this path here, v1 project service accounts, and then the name of it's actually a different one. Anyway, I'll update that image later. Um, yeah, so here, this is the we are authenticating as ourselves. So we are a runner, and we're providing the access token here via the gcloud auth print access token command. So it's runner that is running this. We're executing this command in the context of runner because we're providing the access token for runner. And then we're saying, well, we want to act as a delegate, someone who's delegated us permission, and that is this service account here. So Terraform, and we want to get the access token. You can't really see it here because it's it's snipped off a little bit, but um, we're effectively requesting the access token um, for the IT181 account. So similar to project names, if you have a very common word such as IT, then GCP will automatically append 3 digits after it, just to ensure its uniqueness and to prevent any speculative brute force attacks. So let's run this command as runner. And we get the access token. So this access token here is for the IT181 account. And we leveraged our implicit delegation permissions on Terraform to generate an access token. So that is the key kind of action that we're performing here. So we're doing pretty good for time. Let's take a quick 5 minute break, and then we will come back and do another demo. So we'll take a quick break for 5 minutes, and we'll be back at 1 hour on the clock. All right, folks, let's crack on. So we are going to carry on with enumerating Google Cloud Storage using HMAC keys. So it's kind of worth keeping in mind that HMAC keys are really only scoped for Google Cloud Storage. You can't use HMAC keys to enumerate IAM or any other services like that. And yeah, they pose a security risk because they are long-lived static credentials that can be used to access Google Cloud Storage without identity verification or IP restrictions. We'll also touch on a bit later how there's also a lack of visibility in terms of auditing as well. But to be fair to Google, they do prevent key creation by default. However, if you enable service account key creation, at the organization level, this does also allow at the same time being able to create HMAC keys for service accounts. So worth kind of keeping that in mind. Yeah, so the access keys are in this format here. So you have like Goog and then a long string. And then you have like a secret there. So you have the access key ID and a secret access key. So it's very, if you're familiar with AWS, it's just like that, apart from it's restricted to cloud storage only. So let's do a demo on this. If you recall from earlier, then for cloud storage, we can use gsutil. So let's go ahead and use gsutil. We can use the command gsutil config a. And it says this command will configure HMAC credentials, but gsutil will use OAuth2 credentials from the Cloud SDK by default. To make sure the HMAC credentials are used, run gcloud config set pass credentials to gsutil false. Now, the number of times I've just ignored this message and set my credentials and been like, why isn't this taking effect? And it's because it told me I should run this command first. Otherwise, it's going to use the OAuth2 credential. Let's plug in the key ID and the secret key. Okay, and then it says there is a config file that's been created. So in terms of storing the credentials and potentially, storing credentials securely at rest or on disk. The credentials in this .boto file are in plain text. So if you compromise a workstation that has gsutil configured or gcloud, to be honest, they're both equally as bad as each other in terms of exposing credentials in plain text. But yeah, or if you maybe have it's a slight edge case maybe, but if you have like path traversal, then you may be able to get the credentials that way as well, if they're set. So let's check out this file. And we see here, right at the bottom, we can also authenticate using a client ID and a client secret. In terms of OAuth, a client identity, which we're more familiar with in terms of Azure Service Principles. So the actual credentials for gsutil, it's quite hard to see because it's all the same color, but somewhere up here. Yeah, there. So the Google credentials have been saved to this file here in plain text. Okay, so now if we wanted to use this and go gsutil, maybe ls, just to like list the buckets. and it's going to say access denied. And you might spend a very long time, thinking why, um, thinking why you don't have access to that. Actually, I think I've already changed this setting. So this, I was expecting that to fail for a different reason, to be honest with you. So we got this command, we got this kind of output, didn't we? We had to set that to false. So I think I've already set it to false, to be honest with you. So let's set that to true, and then try and run that command again. Yeah, exactly. So this is now trying to use the OAuth credentials that we set with the gcloud command via the service account key file. And now we see that we still get access denied, but it's the runner service account that it's reporting does not have storage.buckets.list permission. So this is a bit of a gotcha when you're first using gsutil to make sure that you set this property to false, so that instead of passing the OAuth 2 credentials, it will use the HMAC keys in the BOTO file. So gsutil, let's see if we have the ability to list all buckets, and we don't. So we don't have the ability to list the buckets here, but in the error message, we see the service account that the HMAC keys belong to. And even better is that we have the project name, which is AI Innovation, and then a 6-digit string that's been appended for uniqueness and essentially to prevent brute forcing and stuff like that. So let's go ahead and instead maybe we'll have more luck if we actually set the project. You think maybe that the project would be implicit if it's from that project, but there may be multiple projects that it's a part of. So let's say P. We specify the project, and we see 3 storage buckets. So one is aiinnovation.appspot.com, staging.aiinnovation.appspot.com. We see a storage bucket named models private. Now, it's actually worth noting that Google state very clearly in their documentation when creating S3 buckets, they do not recommend adding the project ID to the bucket, right? And however, it kind of appears like they don't really follow their own guidance in this regard, because these are automatically generated buckets created by the AppSpot service. And you see here that Google have created buckets with the project name in them. So it's just a little something to keep in mind as well. Okay, so we could kind of obviously investigate these buckets, but let's kind of move on for now. We've kind of shown the general technique there. So service accounts aren't the only principals that can create HMAC keys. Service account HMAC keys are auditable, so an admin can list the HMAC keys that have been created for service accounts, which is great. However, user accounts are also able to create HMAC keys. And these user HMAC keys are not auditable. So this creates a persistence risk whereby a threat actor or anyone could create a key and use it to continue to access any cloud storage that a principal has access to, that user has access to, even if their password subsequently changes. So that's something to keep in mind. Any user that has the resource manager.projects.get permission is able to create HMAC keys for themselves. And this permission is included in commonly used roles as well. So we see here an example, looking at a specific buckets. Looking at the buckets in, looking at cloud storage and the interoperability in the AI innovation project. We can create an access key for our user account, and we have gone ahead and done that. So an access key and a secret key have been created, and the admins of Gigantic Retail wouldn't be able to tell that that has been created. And there's been interesting research on this. I will actually provide a link to the blog article. There's been some interesting research on this that has been done as well. And in terms of, you can create hundreds or thousands of these keys, and there doesn't seem to be much of a limit in terms of either rate limiting or the max number of keys you can create. Okay, so the next thing really is identifying malicious activity using Google Cloud Logging. So we did mention we'd have a little bit of a look from a blue team perspective as well. Cloud logging is a very powerful solution in GCP that can be used to detect abuse of potentially dangerous lateral movement permissions that have been used by threat actors. So we can analyze the audit logs that we get from the imcredentials.googleapis.com service. In this case here, we are looking for these abusable permissions here. So generate access token, sign JWT, sign create service key. There are other abusable permissions as well, but we've only really added those, to be honest with you. So let's, what if we can actually go ahead and actually do a little demo of that? Oh, no. So I'm just logging into the GCP portal now. Then we'll go to cloud logging. Oops, that helps if I type it properly. Let's select the project, which is AI, actually no, select DL pod one. And then go to cloud logging. And then go to Log Explorer, Logs Explorer, rather. So we see a whole bunch of logs here, which is interesting. This one is particularly, if we can select this in. Okay, there we go. So it's kind of hard to see, I guess, a lot of the fields are collapsed by default. And the text is quite small, so you maybe can't see exactly what it says, right? But it's effectively saying that the runner account that we compromised has used the generate access token method So something that's actually really nice about GCP and cloud logging is the integration it has with Gemini, the AI. So it's got a little button here. Let's see if we can increase the size actually. So it's got a little button, if I can see it now. Yeah, so it says explain this log entry. So let's click on that. So if you're an admin, kind of you've got this alert, maybe you've fed it into your own scene. You need permissions for this action. Would I have permissions? Oh, that's weird. I did have permissions. Maybe they've gone. Anyway, it's a very useful feature, and I did use this before, as we can see here. So let's minimize that for now. So effectively, you get. Oh, I thought that had the AI description as well. Anyway, it doesn't matter. A little window pops up on the right, and it's basically like a chat bot. It's got a prompt where you can kind of chat with and speak with it about the logs. And it just seems like a really great way of analyzing instances with an AI assistant there. So something that, from a blue team perspective, seems to be quite a powerful feature. And so the log entry that we saw, or maybe didn't see, but this really indicates that the service account runner initiated a chain of service account impersonation to generate an access token for the ultimate target account, the IT service account, IT181, via the Terraform account. So this Terraform account has permissions binding runner to be implicitly delegated. So runner can perform actions as Terraform. It can't necessarily generate an access key for the Terraform account or sign a JWT for a Terraform account. But if the Terraform account has any permissions itself on other accounts, then the runner account would be able to do that. And so that's what we leverage. The Terraform account had permissions to generate an access token for the IT account, and the runner account leveraged the Terraform account to do that. Okay, folks, so that is the kind of hacking demo part done. I kind of just wanted to, before we go into the CTF, very quickly touch upon the upcoming GCRTP bootcamp. Obviously, we can have some questions at the end as well. So yeah, this is a bootcamp focused on Google Cloud Security. We can get hands-on experience with attacking and defending in the Google Cloud. It is a live 4-week long instructor-led bootcamp, just the same as the other bootcamps that you may be familiar with already. So yeah, you can expect to learn trending techniques such as the threat actor triple strength and leverage tradecraft and detect tradecraft used by real threat actors. It'll be a mix of a config review, external, and assume breach scenarios, and it will also involve exploitation of active users as well. So it's a little bit of red teaming as well. Yeah, so it covers both GCP and Google Workspace. So that is something that's quite interesting. I think not many folks have covered Google Workspace security. So that's something that is, yeah, interesting that we do. And yeah, so what do you get? You get lifetime access to the custom Cloud Lab environments that we cover in the live sessions. This effectively will be the largest Google Cloud lab playground in the world. You get structured learning paths, Discord channels, cohort, and all the materials as well. You get 2 attempts for the exam, and also and 45 days platform access to access all the labs. And if you have any questions about this, then feel free to let me know. So before we start the capture the flag and kind of give the details of the entry point, I want to just ask if you folks have any questions. Okay, then let's get to it. So this is the Google Security Capture the Flag. The CTF winner gets a voucher for the GCRTP. So good luck with that. I will also put the slide in the Discord channel as well. The starting point is here. So we're starting an engagement for a new client, Gigantic Retail, who have provided us with a link to securely download the credentials to start the engagement. How bad could their security be? Let's find out. So this is the URL, which if you visit it, you can download the credentials to get started with the engagement. And there is a flag. So if you get the flag, please DM me in Slack, and the first person will get a voucher for the GC RPT bootcamp. And on that note, I'd also like to thank you all very much for being with us today. And yeah, if you have any questions about this in Discord at all, let me know. I'll be adding the PDF also to Discord now. So yeah, thank you very much.